Have you ever heard the word harmony? You must have heard it in music, seen it in arts, or in dancing. Well, in this video, you will hear the word harmony in our lesson, Kepler's third law. Kepler's third law, sometimes referred to as the law of harmonies, compares the orbital, period, and radius of orbit of a planet to those of other planets. Unlike Kepler's first and second laws that describe the motion characteristics of a single planet, the third law makes a comparison between the motion characteristics of different planets. The comparison being made is that the ratio of the squares of the periods to that of cubes of their average distances from the Sun is the same from every one of the planets.
As an illustration, consider the orbital period and average distance from Sun, orbital radius for Earth and Mars as given in the table below.
Observe that the t squared over r cubed ratio is the same for Earth as it is for Mars. In fact, if the same t squared over r cubed ratio is computed for the other planets, it can be found that this ratio is nearly the same value for all the planets. Amazingly, every planet has the same t squared over r cubed ratio. So here are the table for the planets' period, average, and ratio. A side note, the average distance value is given in astronomical units, where 1 AU is equal to the distance from the Earth to the Sun, which is negative 1.4957 times 10 raised to the power of 11 m. The orbital period is given in units of Earth years, where 1 Earth year is the time required for the Earth to orbit the Sun, which is negative 3.156 times 10 raised to the power of 7 seconds.
Kepler's third law provides an accurate description of the period and distance for a planet's orbit about the Sun. Additionally, the same law that describes t squared over r cubed ratio for the planet's orbits about the Sun also accurately describes the t squared over r cubed ratio for any satellite, whether a moon or a man-made satellite, about any planet. There is something much deeper to be found in this t squared over r cubed ratio, something that must relate to basic fundamental principles of motion.
Now that we are done with this lesson, we may wonder what could be its benefit to us. So, here it is. First, it helps us in determining the masses of the planets. Kepler's third law can be used to determine the mass of a planet or star, which is crucial to understanding the dynamics and evolution of planetary motion or system. So, in conclusion, Kepler's third law of motion is not only important to the astronomers but also to us students, because it provides valuable insights into the motions and characteristics of celestial objects and advancing our understanding of the universe. That's it.